Welcome back to Introduction to Programming. This is video 7 in our series, and my name is John Duane. Last time we covered computer hardware, specifically disk and memory devices, and why they are important in the design of your computer program. I introduced the concept of variables, containers for data, and how the smart programmer will think ahead to what kind of data will go into those variables and then declare the variables with the appropriate data type. The objective of the smart programmer is to use the data type that is not too small or not too big, but just right. Naturally, when there's significant doubt about the size of the data going into your variables, err on the side of too big. Now today, we're going to look at an example that uses variables extensively. I will talk about best practices in picking names for your variables. I will introduce another programming convenience called the constant. One cannot have a demonstration of variables in a computer program without dealing with scope. You don't know what that means yet, but hopefully after the demonstration you will. Plus, there'll be some other goodies. And since this is a program that really works, it will be another opportunity for you to see how we construct computer programming expressions. It's like the English language: subject, predicate, and object. So, here we go. Let's look at the interactive development environment. And here we are. So I've already written this, so it's ready to go. But we'll make some changes along the way just so you can see how it works. So what we see here on the IDE are two small programs. You can tell there are two programs because there are two groups of code lines surrounded by sub and end sub. So sub and end sub down here. Notice above the first program, I'm declaring a constant and a variable. Constants use the keyword const, C-O-N-S-T, as you can see here. Unlike variables, you declare a constant and then assign it a value all in the same statement. The variable is declared as a string data type. Its value will be assigned later. The other thing to notice is that these items are outside the two programs. See, the first program starts here, and these are declared above it. That gives these two items what we call module level scope. What that means is that they have to be declared only once, and they will work in all programs inside the module. The variables declared inside a program, like these, will have local scope and will only work inside that program. Okay, all right, you might say, who cares? Declare everything as module level scope, and it has to be easier. In this small set of programs, maybe. But when the program gets longer and more complex, you might like local scope better, because then you can use the same variable name over and over, which might make your program easier to read and to maintain. Now let's look at the first program. It declares three variables using int, long, and double. All right, so these are all numeric. Notice that the variable names begin with a lowercase prefix. See that? Int, LNG, and DBL. That indicates to the reader the data type of the variable. Now that in and of itself doesn't make int number an integer, but later on in the program, when you're far away from these particular lines of code, it'll be easy to tell that int number is an integer. So this is a best practice in VBA, and it really helps in long programs. Next, values are assigned. The value being assigned to the integer is the highest possible value it can hold. Then a much bigger number goes into the long. and a number with decimal places goes into the double. The string text variable is being used over and over again. You can see here, here, and here. With each message box to deliver a different message along with the number. Finally, the constant is used as the title of each message box. You can see that at the end of that expression. So that's always the same. All right, so let's run it. Let's see what happens. So we'll click the run button, and okay, so there's message box number 1 with our integer 32,767. There's our long with, I can't remember if that was 10 million or 1 million negative. And there's our double with the decimal places. And we'll click OK, and we're all done. Now let's make some changes. So I think you recall that integers can have a number as high as positive 32,767. That's 1/2 of 2 to the 16th. Let's make that an 8. And on the long, because this is a long integer, that's what it's called, let's get cute and put some pennies on there. All right, let's see what happens now. Overflow. So let's hit the debug button and see where we are. It's here. So the int number won't take 32,768. It's overflowing because it needs more than 16 bits for a number that big. All right, so we're going to have to change that back to 17 or to a 7. And now let's keep going. So now that works. Display the long integer. Hey, what happened to our pennies? They're not on there. That's because an integer can't have decimal places. And so here it gets truncated off. It's just ignored. And the third one is the way we had it in the first place, which is fine. All right, so you got some examples there of the types of errors you can get. You can either get a straight up error message in a little window displayed before you, or the answer to your programming question will just be wrong. And that was the case when the 22 cents wasn't there. Okay, let's go down to the second one. Here we're not talking about numeric values, but we're going to have date and Boolean data types. So remember, Boolean is true and false. The next interesting thing that this program does is it assigns to the variable dt today, see that right here? It assigns the current date. And it does this with the VBA function today. Or actually, the VBA function date, which gives you the current date. So that's pretty handy when you're working with dates. Now then, the next interesting thing is down here. This is new. This is the InputBox function. And this function collects data entry from the user in a dialog box. And here we're asking for a date. Enter a date in the past. The next section checks to see the date entered by the user is really in the past. It uses if then else. The Boolean variable is set to either true or false depending on the result of the test. If the Boolean variable ends up with a false, the program displays a message box with an error message. If true, the program calculates the difference between the past date and today. You can see that down here in parentheses, and displays the difference in days. So let's run it. So we have to put a date in the past. So we'll put in, how about 12/31/2010. That's not I didn't do that right. There, that's 2010. We'll hit OK. And days between dates is 1,369. Okay. Let's try doing something wrong here. Let's put a date that's not in the past. See what happens. 12/31/2014. So that's not in the past. And here we go. There's a problem with DT past. So here it didn't pass the test. So there you have it. In our example, we looked at how to name variables, how to declare them, how to assign values to them. We also saw what can go wrong when you pick the wrong data type for your data. We also saw the InputBox function, the date function, and we did some math with dates. I think you're ready to start writing some test programs of your own now to try out some of these ideas. Don't be afraid of making some mistakes. It's the best way to learn. If you get stuck, just Google the problem and you're bound to find someone with the same question and 100 people with the answer, really. So have fun with it. That's it for today. Please write comments on your YouTube page and subscribe. See you next time.